Which of the following describes the shaded region? Is it Roman numeral 1, -5 is less than x, which is less than 3? Is it Roman numeral 2, x is greater than -5 and x is less than 3? Is it Roman numeral 3, x is greater than -5 or x is less than 3? Is it Roman numeral 4, the absolute value of the quantity x plus 1 is less than 4? Or is it Roman numeral 5, a solution of all numbers x whose distance from the origin is less than 4? Well, we can clearly see in this problem that we have open circles at -5 and +3. And from +3, we shaded to the left, so it's less than +3. And then we shaded to the right of -5, which means it's greater than -5. So Roman numeral 2 is definitely true, and so is Roman numeral number 1, because you can take the and inequality, and instead of having it as x is greater than -5, you can rewrite it as -5 is less than x, and x is less than 3. So then you put that at the end of it to create this compound inequality. If we actually look at Roman numeral 3, we now have x is greater than -5 or x is less than 3. Now, if that was true, our graph would go greater than -5 all the way up the number line, and it would go less than 3 all the way down the number line and would make it an all real numbers solution set, or from -infinity to +infinity. This one is not true, so we can rule it out. So therefore, answer choice B can also be ruled out because Roman numeral 3 does not represent this shaded region. Now let's look at Roman numeral 4. So in Roman numeral 4, we have x plus 1, or the absolute value of x minus -1 is less than 4. If you remember, we have the absolute value of x minus c is less than d, produces the compound inequality. So is -1 our middle point? Well, let's actually put an x there for a minute and now count 1, 2, 3, 4. 1, 2, 3, 4. Oh, it does indeed work. So this one is also a true statement. Now let's look at 5. A solution of all numbers x whose distance from the origin is less than 4. Well, the origin is here at 0. Are all of the values or accepted values for x 4 away from 0? No, we have 3 away from 0 in one direction and 5 away from 0 in the other. So this one's definitely not true. And we have proven that Roman numerals 1, 2, and 4 all work. So therefore, the correct answer here is choice C.